morning, good evening, everyone. Welcome to this session on global 6G initiatives. My name is Alexia Gonzalez Fanfalone, and I'm a telecommunication policy analyst at the OECD. I have the honor of moderating today's session. It is a real pleasure and honor to welcome speakers today, seasoned experts from the policymaking spheres, the private sector, and academia from all over the world to start a conversation on different initiatives shaping the development of an increasingly connected world beyond 5G. Let me start by setting the stage here. What is 6G? The short answer is, this is yet to be defined during this decade. For previous mobile generations, it took around 8 to 12 years between the time the vision was set, the technological standards agreed, and commercial deployments commenced. As we speak, the ITRI Working Party D has already started its work on the vision and IMT beyond 2030. So in a way, what we're having today is a very forward-looking conversation. We're gathered to discuss a vision on what may be the next steps of convergence of communication networks beyond 5G. Like with previous generations, there will likely be evolutionary aspects of this technology, as well as revolutionary ones as new technologies are developed. Some that we've heard are, for example, terahertz communication and sensing, immersive, extended reality, holograms, etc. In terms of research, industry alliance, and government initiatives, countries across the globe have started to work on what will be the vision of 6G. We are lucky today to have set in this session representatives of different regions to touch upon this question. So, will we have a hyper-connected world in 2030? If so, what are the implications? Importantly, what are the requirements? Are there new risks and challenges? When talking about new connectivity solutions for the future, how do we ensure that we reap the benefits of these solutions for society as a whole? Today, we have experts around the table to kick off this conversation, a nascent discussion on networks of the future that will probably last for years to come. Before we kick off the session, it is an honor for me to present our distinguished speakers in a brief manner, of course. Bringing a perspective from Europe, and as a policymaker, we have the honor to welcome Mr. Bernard Barani, Deputy Head of Unit for Future Connectivity Systems in DG Connect at the European Commission. From North America and with an industry perspective, we have Mr. André Fuetsch, AT&T's Chief Technology Officer, who is spearheading the design of the company's next generation wireless infrastructure. We also have the honor to several speakers from Asia. Mr. Brijendra Syngal, also known as BK, a seasoned telecom expert who is chairing the 6G Council in India and working at present with the ITU on the topic. We also welcome Mr. DongKu from Yonsei University and co-chair of the 6G R&D strategy in Korea. In addition, we're glad to have with us Ms. Fung Chang, Chief Architect of the 5G Program Office in Taiwan, and Mr. Zhisheng, Professor at the Department of Electronic Engineering at Tsinghua University, China. Without further ado, I will now give the floor to Mr. Bernard Barani, Deputy Head of Unit of Future Connectivity Systems at DG Connect. Please, Mr. Barani, the floor is yours.
Thanks a lot, Alexia, and many thanks for having me at this event. So next slide, please. Well, that works, that's perfect. No, the slide before will do. Just a few words of introduction about myself, who we are in the European Commission. I belong to a division called Future Connectivity Systems, where basically we have two main responsibilities. One is to set up the right framework conditions for 5G deployment or for technology deployment in Europe. That means investment incentives, the right regulation, and these type of activities. And the other leg of our activities is to support industry competitiveness through research and innovation programs. So that's on this part. I'm gonna talk more in this speech. And to tell you where we come from, we started the 5G public-private partnership in 2013, which is now coming to an end, which was our support arm in partnership with industry to support European competitiveness in 5G. And now we are trying to move into the 6G era. So next slide, please. So when we look at the overall picture, we believe, of course, that it's a very timely move, taking into account all the international developments and all, let's say, maybe the hype, which is now raising around on top of 6G or beyond 5G type of initiatives, where we see, first of all, what is very interesting is to see that the United States, which was leaving this type of, let's say, developments in 5G to market forces and concentrating actions on spectrum assignments, is now coming much more boldly into support to dedicated initiatives. Japan also has quite a few interesting actions which are developing, and they have published beyond 5G roadmap already mid last year. Same in Korea was last September. China started already in 2019 by renaming the IMT 2020 promotion committee as IMT 2030 promotion committee, and starting to kickstart reflections on beyond 5G. And on our side, we are now trying to put in place an initiative which will be, in principle, a framing initiative in Europe, which we expect will have a 900 million contribution on our side. But what's interesting is that also in several member states, in particular Finland, Germany, we have already initiatives which have been started around 6G, the latest one being the German one for 600 million euro that was announced a couple of weeks ago. What's interesting is that in some of the initiatives, we see also a strong drive around the Open RAN. So there is a kind of message around the Open RAN being 6G type of actions. On our side, I was quite interested to hear Professor Tafazzoli yesterday when he said that what is not 6G, he said Open RAN is not 6G. So we believe that Open RAN will probably be one of the components of 6G, but to reduce it to 6G is maybe a little bit an overstatement. So next slide, please. Now, when we look at where we started from in 5G in 2012, 2013, I mean, there are a number of factors of change from an industrial perspective. First of all, we see that vertical industry is much more present in the overall landscape or in the overall ecosystem, and this was recalled by the keynote speech of Dr. Müller, Andreas Müller from ASIA, 5G ASIA yesterday. We see that we have a lot of expansion or buy-in from the technologies which are coming from the software and the cloud environment. I mean, 5G was really a kind of starting point there, but now it's expanding. In Europe, we are talking a lot about strategic autonomy, sovereignty, which means that from our side, it means to have much more presence in the microelectronic and components type of activities, especially in processors. We see that all over the world, networks are being considered nowadays as critical infrastructures, and cybersecurity is front stage. Human centricity, what we call human in the loop, is again even more important than was before. And we can see also that compared to the starting point in 5G, we have many more business models beyond operators that can be considered for deploying these technologies. So this, in our view, has probably a potential impact on the set of stakeholders, the set of alliance and collaborations, how we can look into future standardization and how we can stimulate deployment in the future. So next slide, please. Now, we have been working with stakeholders in Europe already for more than 2 years on what could be beyond 5G, and we have identified a number of orientation for 6G, where we look at the top of this chart first of all at the application perspective. So if there is a 6G, it has to provide new type of applications. But on the one hand, we cannot completely get rid of the past. So if we look at the top right-hand side, we believe that the vertical use cases journey that was started with 5G will still be a very, very strong driver to promote new type of systems beyond 5G with new type of KPIs and new type of requirements. that will probably go beyond the speed, latency, reliability KPIs that have been identified for 5G. And we see this already happening in certain environments such as factories or such as automotive or even healthcare, where some of the sub-use cases are really pushing the envelope of what is possible with 5G. Then on the left-hand side, we have another set of applications which are probably even more innovative, holographic communications, all the let's say the applications which are coming from the immersive environments, digital twins, holographic communications, or extended realities are applications which are to a certain extent already possible today, but which will probably push the envelope of what is possible with 5G, especially in terms of scale. And then we have totally new universe to explore, such as the Internet of Things, or which is related to this notion that the Nokia speaker yesterday mentioned, the convergence between the physical, the digital, and the biological world. And these are really totally different type of applications which probably will be, let's say, further explored with 6G, the 6G journey. Now, at the bottom of this chart, we have a strong focus on societal issues. I mean, societal, we believe, is something that has to be looked into from several perspectives. The Sustainable Development Goals were already identified yesterday by the keynote speech of the NXP speaker, and we believe this is a strong focus to develop new platforms, be it in terms of energy efficiency or in terms of affordability or accessibility of the technology, in terms of openness, in terms of contribution to climate change, or even to education or agriculture. We believe that these are very strong policy elements where we have to invest much more than what we did with 5G in the past. And in the middle, what you have are the issues which are related to the management focus and the possibilities to have new platforms with even lower OPEX, high flexibility, and enabling the high, let's say, return on investment, which is to be found at the application level. And here we can think of specific technologies applied more systematically, such as artificial intelligence, to increase the flexibility of the networks or to increase the flexibility of the platforms, to really move towards this computing and communication continuum that we have started again with 5G, and to have the ultimate level of flexibility that enables function placement at every place in the network, depending on the use case requirements. And of course, ultra high security trust comes as very strong requirements. And again, here we have some technologies to look into the possibilities to make that happen. So next slide, please. Just a few words on KPIs. I will not go too far into the details because this was presented already yesterday. So we have already some ideas of how the KPIs, how the boundaries, the boundary constraints of the 5G KPIs could move into new type of 6G KPIs in terms of speed, in terms of capacity, in terms of latency. This speed capacity being very much driven by immersive type of environments, as I said, or even hologram type of communications requiring a very high data rate, user data rate. But what we believe is that we have to complement these KPIs, but what some people call KVI, key value indicators, which are really measuring and quantifying the societal efficiency of the platforms that we are putting or that we are deploying. And this, in our view, is a work that needs to be done, and that we will try to do with the stakeholders in the next few months and years. So next slide, please. So I will not go too much into the details of this slide, but this is just to illustrate the fact that when we talk about societal challenges, this is not just a theoretical thing. We can identify for classes of societal challenges such as energy, affordability, human centricity, security, EMF control. We can identify technological approaches that can potentially satisfy the requirements which are behind. So I will not go too much into the details, but for energy efficiency, of course, we can think of massive fiber deployment, which are going close to the or down to the access points. But on the other hand, if the density of the network increases, the energy consumption increases. So there is kind of trade-off to be sought here. Also, if we move very much into this computing and communication continuum with edge computing capabilities, there will be a trade-off to be done between what energy you consume at the level of transmission and what energy you consume at the level of computing, and this will be let's say a subject of dedicated work on architectures that needs to be undertaken. The same for using platforms to increase the energy of efficiency of vertical users. We have already today some ideas and some analysis on how connected cars or automated cars can, for instance, increase the energy efficiency and reduce the CO2 consumption or the energy consumption of a vehicle. But we believe that this is a work that needs to be done for many more verticals, which has not just started yet. Affordability, accessibility, when we move into software type of implementations, cloudification, disaggregation, these are issues that potentially reduce the market entry barriers, whilst we have always non-terrestrial network options to increase coverage. So there are a number of technologies that can be looked into. I will just finish this one by stating that EMF control is a very strong concern by populations, and even there we see some technological approaches to have better control of EMF, such as reflective intelligent surfaces, which were kind of described already yesterday. So we see that we have a panel of technologies and architectures that we have to think of to make this happen, and this is potentially very fruitful. So next slide, please. So we have started already our 6G journey, if I may say so, by launching beginning of January this year, 9 exploratory projects for a total envelope of 60 million euro. So we have one flagship project called ExaX plus 6G exploratory project on specific technologies such reflective intelligence surfaces or artificial intelligence, function placement, these type of things. This is fueling, let's say, it's acting as a kind of bridging phase into what we call the Smart Network and Services Joint Undertaking, which we expect to launch by the end of this year, for which we have support of several or multiple industry associations, as you can see at the bottom. And within this partnership, we expect to have 2 legs. One leg which will be promoting 5G deployment across pan-European cross-border corridors in Europe, taking connected cars as a dedicated use case in Europe. And the second leg will, of course, be to work on the 6G vision and technology. So next slide, please. So well, this is just to illustrate that what we intend to do with this initiative is to take what we call a value chain approach. So we will not concentrate only on the network activities, but we will concentrate on the network, device, cloud and edge activities, and trying to reap the benefits of this activity to also recreate capabilities in the component domain or in the microelectronics domain, so to increase our capabilities that in that respect. So we'll try to work out in such a way that we consolidate European capabilities at the device level and also create capabilities in Europe at the level of edge platforms and edge computing servers. All this, of course, from the perspective of being covered from an horizontal perspective by energy efficiency and trust and security. The next slide, please. So that's the timeline. We very rapidly, we expect that the standardization, let's say, race or the standardization kickoff will start around 2025. Between now and 2025, there is a window of opportunity for very strong research, either at the level of elementary technologies or at the level of systems. We intend also to contribute to the ITU process that Alexia mentioned in her introduction, which is to have key trends and technologies mid next year and to have the vision early 2023. So next slide, please. So where we are, we have developed a number of key documents which are framing our initiative. So you may want to have a look at these websites. I don't have much time to expand into those, but the strategic research and innovation agenda basically depicts all the research and innovation actions that the stakeholders believe are important to tackle. The deployment agenda is more of an agenda framing deployment initiatives, especially for connected cars. Then we have the industry proposal, which has been, let's say, given to us by all the industrial stakeholders of Europe, the relevant stakeholders, to manage this initiative. And then the Single Basic Act is a legal text that we are currently discussing with the European Council to give birth to this initiative. We still have a number of legal processes to go into this. Next slide, please. So this is just where we are. So for the legal act establishing the joint undertaking, the initiative, including the commitment of the 900 million that I mentioned, we are still discussing this with the council. We expect to have this legal act around Q3 this year. And we are in parallel working with the stakeholders on the first work program of this joint undertaking, which would be a tranche or a slice of 240 million euros that we would commit by the end of next year. Next slide, please. So that's my end, and here are a couple of additional information that you can have from public sites. And at the bottom of this slide, you have some publicity for our conference in Porto in principle, but unfortunately it will be a virtual one, from 8 to 11th of June. And here we will present in more detail whatever we do in Europe and our future plans. And with this, I conclude this presentation, and I thank you very much for your kind attention.
Thank you very much, Mr. Barani, for your excellent presentation. If I may, I would just like to pose a question on what you presented. You led the Commission's work on defining and implementing the 5G PPP, which was launched in 2013 to support 5G European R&D. And during your presentation, you mentioned the Commission plans to support a EU-led 6G initiative. And the question would be, is this really like a continuation of previous efforts, or are there any difference between the new EU-led 6G initiative with respect to previous or earlier 5G initiatives in terms of the policy focus?
There is a clear difference in terms of stakeholders and in terms of policy ambition. And that's the reason why we have selected a vehicle for implementation, which is different from the vehicle for implementation that we had for 5G. For 5G, we had a loose public-private partnership that was a kind of gentleman's agreement between us and industry. Here we have something which is much more legal, so it's really a kind of contract that we establish with industry. And we see it because we believe that the level of ambition is much higher in the context of, first of all, the set of stakeholders. We clearly do not want to limit ourselves to the connectivity segment, but we really want to include the device side, as I said, and try to stimulate also capabilities, European capabilities in the domain of components, be it RF, RFICs, or processors. This is something that we did not have in the 5G PPP. And this is a domain which is very close to the heart of our commissioner, Mr. Breton. He's very much enthusiastic and about this domain of components and microelectronics. So this is something we really have to expand our activities on that. And at the other end of the scale, upwards toward the services, the idea is really to regain grounds and capabilities in cloud, edge, and service platforms, which is a domain where Europe is not very strong at this moment in time, as an understatement. And here we clearly have an industrial approach which is much more comprehensive compared to what we have had with 5G. Also, the second difference in my view is that we put a lot of emphasis on societal challenges, and we will certainly invest a lot of efforts to support our Green Deal policy and to make it such that we end up with platforms which are energy aware, where energy efficiency can be much better controlled, and where the contribution to the carbon footprint of vertical use cases can be, let's say, positive and contribute to reducing the overall carbon footprint as per the political objectives of the Commission. So it's more ambitious.
Thank you very much for that. I note your notion of Green Deal and the Green G, as well as also the contract with the industry. So the level of engagement is a bit more formal, and it's very interesting. So just within the European initiative, you also mentioned that this is part of a wider context of other initiatives across the globe. And from your perspective, is there a likelihood of that these different initiatives, at least from the technology cooperation point of view, will converge medium, long term? Do you have any thoughts on that?
We certainly have the ambition and the intention to stimulate global standardization and the global standardization process. That means that we will continue to support global standardization and global consensus around standards. Now, in our view, it's a little bit too early at this moment in time to exactly define the boundaries of the international cooperation agenda that we can put up front. It very much depends also on the industrial policy initiatives that we see developing in other parts of the world. As I said, for instance, to give you a very precise example, some of the initiatives that we see developing are very much framed by the idea of developing a new industry around the open RAN type of principles. This is not an element where we will put a lot of emphasis, even though the principle behind Open RAN, which are disaggregation, softwareization, cloudification, automation, this we will, of course, promote in our initiative. But again, depending on the boundaries of the initiatives in the world, we have to look in a case-by-case basis. And to do that, what we are doing at this moment in time is that we are expecting a proposal from the industrial side, the European industrial stakeholders, to tell us how far we can engage into international cooperation. And on this basis, we'll take some decisions. But for the moment, we have not yet taken any particular position on that. So we see a little bit to see how things develop and what are the potential elements of the various initiatives worldwide where we can have common interests. So we are a bit in a wait and see situation at this moment in time.
I see that there's an excellent answer. Thank you very much, Mr. Barani, for your presentation that provided an overview of all initiatives as well as what's been done in Europe and where we're going. Thank you very much for your excellent answers as well. And now we have our next speaker, who is Mr. Andre Fuetsch, AT&T's Chief Technology Officer. Given the very early hours in the United States, Mr. Fuetsch kindly sent a video for us to see. So let's listen to what he has to say. Thank you.
Welcome, I'm Andre Fuetsch, CTO of AT&T, and I also serve as the chair of ATIS and the NextG Alliance. Today, I'm going to talk to you a bit about the path to 6G. AT&T continues to lead the charge to unlock the power of 5G for consumers and businesses, including bringing new ultra-fast 5G experiences to universities, military bases, hospitals, stadiums, factories, and more. Our initial deployment strategy used millimeter wave spectrum to offer 5G in iconic destinations and key venues, where demand on our network is high and extra capacity and coverage is needed. In 2021, we'll continue to expand this network. Additionally, we began deploying 5G on our sub-6 low-band spectrum holdings across select market areas in December of 2019, which reached nationwide in July of 2020. AT&T's 5G non-standalone core is fully virtualized and running on COTS hardware, We are currently developing and testing our next-gen core to enable cloud-native network functions and network slicing, and we continue investing in our network infrastructure to build out our 5G services. Our long-term goals are to bring AT&T's 5G to more consumers, businesses, and first responders across key areas: sports and venues, entertainment, travel and transportation, business transformation, and security and public safety, including FirstNet. Over time, 5G is expected to deliver latency and capacity enhancements that will enable revolutionary new capabilities for consumers and businesses. The combination of lower latency, massive connectivity, and faster speeds will create opportunities to transform retail, make autonomous vehicles a reality, and make it possible to build smart factories and revolutionize healthcare. Lower latency. Think of this as the time you hit the enter key until you get a response. Massive connectivity. This is the ability to connect virtually everything as we go from hundreds to thousands of things connected in every square meter. And then, of course, faster speeds. That will make everything we do today even better as the ecosystem evolves. Businesses are coming to us for 5G solutions. We are working across a number of industries to bring 5G and related technologies to healthcare, manufacturing, education, sports, and entertainment business customers. As 5G evolves, immersive experiences that blur our physical and digital worlds will come to life. This is all about more deeply connecting people with their passions in ways we couldn't previously imagine, and creating opportunities to transform industries. Entertainment and gaming is a great example. Think of streaming your favorite shows and movies virtually lag-free. Sports and gaming. Get up close to virtual players at the game or to real players at home. And then there's healthcare. This is about connecting patients, doctors, and information in new and immersive ways. AT&T will also launch 20 connected learning centers this year. These centers will be located in underserved neighborhoods where many residents lack broadband connectivity today. Much like 4G introduced the world to the gig economy, we believe mobile 5G will jumpstart the next wave of unforeseen innovation. We're cultivating the ecosystem today, and this will take time as we move from a 4G world to a 5G world at scale. The AT&T 5G Innovation Studio brings together the AT&T business, consumer, and network operations organizations to accelerate the path to market for new product offerings and key strategic initiatives. And while 5G is still early on its evolutionary path, we recognize the need to begin to promote an early commitment and bridge to creating a 5G to next G marketplace, and to ensure North America continues in its leadership role in technology development. Let's now shift our focus to the ATIS Next G Alliance. Almost a year ago, in my role as the chair of the ATIS Board of Directors, we began discussing the critical need for North American leadership to develop a robust 6G market by the end of this decade. North America has long been a leader in driving innovative solutions to market and creating an equal playing field where industry can compete and deliver powerful solutions. As we look ahead, 6G represents an even greater opportunity to extend wireless solutions into almost every facet of human and machine interaction. To ensure the realization of this ambitious opportunity, ATIS developed the 6G Call to Action, a blueprint for industry, academia, and government to collaborate on a strategy to not only move, but to accelerate toward the realization of a North American vision for 6G. In late 2020, the call to action led to the formation of the 6G Alliance and a commitment to build the foundation for North American leadership in 6G and beyond. With strong support from the ATIS Board of Directors, government, and the ICT industry, ATIS launched the 6G Alliance along with its founding member partners. Although the 6G Alliance was launched as a private sector initiative, its primary objective is to influence North American government and research communities. While it is indeed true that every company, institution, and research community must develop its own business strategy and unique product portfolio, the power of a collective vision is a core principle of the 6G Alliance. But this vision is not simply a view or set of recommendations captured in a document. The 6G Alliance will drive actions across a broad range of areas, including policy, funding, research priorities, and core technology development areas. We have seen the 6G Alliance grow quickly, starting with full members and more recently adding contributing members, which include leading research and academic institutions, small specialized companies, and research communities. Likewise, as the 6G Alliance launches its working groups, participation has increased to over 500 technology experts and thought leaders from industry and academia. The 6G Alliance will continue to grow and expand into new areas as its comprehensive work program is developed further. In looking at the 6G Alliance leadership team, I am proud to serve as the chair of the full member group. Jan Soderstrom, who leads Ericsson's Silicon Valley Technology Office, has also been an important part of the leadership team since the 6G Alliance's inception. The steering group acts as the execution arm of the 6G Alliance working groups. It includes a balanced leadership team representing different industry sectors. Nokia, AT&T, and VMware have all brought forth leaders who drive the 6G Alliance's mission while also ensuring the needs of vendors, operators, hyperscalers, and many non-traditional players in the North American industry are addressed as well. Let me now speak to the primary goals of this initiative. First, we must establish 6G and beyond, which we characterize as 6G, as a national agenda priority. Increasingly, we are seeing initiatives across the globe work to drive future competitiveness and economic success in their geographies. And that is the reason we are here today. The goal of the 6G Alliance is to bring together the best minds and the best ideas to firmly establish 6G as a North American priority. Next, we need to develop the best suited model for the North American landscape. While technological solutions and standards may be defined at a global level, regional differences and opportunities must be addressed in terms of societal drivers, geographic needs, vertical market approaches, government priorities, and many other factors. Finally, collaborating on a future 6G vision will establish a robust North American marketplace for the next decade and beyond. Ensuring a vibrant marketplace for more than 300 million North American mobile subscribers will also strengthen and enhance the ability of North American companies to fully capitalize on their leadership in the broader global 6G market. Let me now discuss the concept of a national 6G roadmap, which will set the foundation for other work of the Alliance. A national 6G roadmap working group will act as a coordination point across all working activities to establish a 6G and beyond vision. So what is a vision in this context? A vision should not be a kitchen sink of all possible use cases. In the context of the Next-G Alliance, the vision represents a holistic view of the 6G marketplace and the surrounding environment. Now, let's consider the 6G roadmap. A roadmap connects the present vision to the future vision. It also defines key developments and milestones along the journey to the next decade. That means we should be considering R&D, but also incentivizing manufacturing, establishing high-level standards goals, enabling market readiness, and achieving 6G market realization. This Next-G Alliance lifecycle view is also the basis for the 6G roadmap. We need to translate all these factors into an actionable strategy, encompassing policies, funding priorities, and government actions that incentivize the market. Finally, we need to apply this energy to creating a robust landing place for 6G, where we do the advanced planning, seed forward-looking research, and apply the appropriate actions to promote the innovation and rapid commercialization of 6G markets. We also talked earlier about the National 6G Roadmap Working Group, but we also need to drive thought leadership concurrently across many different segments. The Technology Working Group will look across the entire landscape of air interfaces and radio systems, network cloud fabric, edge infrastructure, backhaul needs, and surrounding technologies. New generations of technology will always lead to transformation opportunities for adjoining markets, so we must approach this assessment holistically. Ultimately, this will lead to a core set of technology developments that drive national funding priorities. In some cases, applications are made possible by technology breakthroughs. In other cases, new applications may be driven by changing demographics, societal shifts, or even new business models. The Applications Working Group will focus on all of these drivers, including how these need to translate into new key performance indicators. Of course, you cannot talk about next generations of wireless technology without considering the spectrum implications. Understanding the spectrum policy, allocation, and management are complex business issues. There are common challenges and opportunities to tackle. The Spectrum Working Group will explore new paradigms for spectrum access, management, and sharing. It will also look at opportunities for global spectrum harmonization, technology coexistence, and greater spectrum efficiency. Recognizing that energy reduction and sustainability are key challenges for the coming decade, the Next-G's Alliance's Green G Working Group will aim to position North America as the global leader for environmental sustainability. As I mentioned earlier, societal needs and economic drivers are key considerations to the 6G vision. The Alliance will identify and characterize these considerations, areas such as societal demands, market needs, operational necessities, economic forces that will impact the 6G marketplace. As you can see, the Next-G Alliance ecosystem is structured to deliver across this entire life cycle leading up to the 6G marketplace. At the top of this diagram, you see the Next-G Alliance advising government funding agencies and research communities on the needs, priorities, and actions related to 6G development. In the center of the diagram, you see the life cycle view that extends from 6G research to realization. This is a critical aspect of the Next-G Alliance construct. Approaching each of the life cycle components independently will not lead to a holistic outcome. That is another core principle of the Next-G Alliance. Starting on the left, the 6G Research Initiative will most likely be a set of 6G research activities funded by NSF, DARPA, and various government departments. The research outcomes are important inputs to 6G development and manufacturing, where government can work with industry to incentivize this part of the life cycle. As you continue to the right, you will see the standard strategy and leadership across the goals of the Next-G Alliance is a critical component. This now leads to 6G market readiness and ultimately to 6G realization. This is where the advanced 6G development activities performed in a coordinated way will combine with other important actions to create a successful landing place for 6G in North America and the global market. Thank you for the opportunity to speak with you today. I hope that you now have a more thorough understanding of both AT&T's commitment as well as the Next-G Alliance's mission to drive a vibrant 6G marketplace as we continue to deliver powerful 5G solutions that transform not only our industry, but all of the customers we serve.
We thank Mr. Fuetsch from AT&T for his valuable presentation. And now I would like to give the floor to Mr. Brijendra Syngal, Chairman of the 6G Council in India. Please, Mr. Syngal, BK, the floor is yours.
Very good afternoon and good morning. Just by a brief introduction, I would like to say that telecoms and internet have impacted our lives in an unprecedented ways. The example or manifestation of that is that we are having this conference virtually connecting all across the globe. Today, major societal and economic trends are defining the needs of the future. The discussion is focused on the interaction between the communications network and the human world, the digital world and the physical world. In such a scenario, we just embarked on a 5G journey. We are starting to discuss what should define 6G. My focus is in this talk is not to delve into details in any particular area, but to hopefully point out perhaps it is time to rethink how we embark on the 6G journey so that we are in the right place 8 to 10 years from now. May I have the first slide, please? It's a given that connectivity is important. It's a combination of innovation, evolution, application, and most importantly, devices in the hands of users or machines or robots, etc. That will drive the next generation of connectivity. We can't stop the march of technology. However, when we talk about generations, we refer to mobile connectivity. By mentioning G, it has a mobile connotation and not any other connectivity. I think that is something which we need to ponder over. I hope the audience will agree with me that mobile connectivity has had its limitation. It has often been too difficult or too expensive to reach users. There has been a lack of ubiquitous coverage. There has been inconsistent user experience. Having said that, the benefits of technology evolution are there for all of us to see. Nonetheless, experience tells us that by the time we reach perfection, we embark upon the next generation. In all this, it is hard to define a perfect service or even definition for a service. I do wonder if this is the right approach and what lessons can we learn from our experiences of the G generation so far. May I have the next slide, please? Let's look at the very 5G scenario today, which is topical right now. While I do appreciate 5G is in a nascent stage, as my previous speaker mentioned that it was introduced in December 2019, and the deployment across the world is happening as we speak. Many countries like India have not yet started mass rollout. Do we think that the fastest go faster stripes version of 5G will be available to all? In fact, there was a league table of 5G speeds, which starts from about 500 MB and going down to about 120 MB or so. There is a dependency. Fastest 5G is available only when the operators provide the ultra-wideband service. What does that ultra-wideband service use? It uses millimeter or universal manner. So we start to see a trade-off between coverage and capacity emerging. If I look at my crystal ball, I see that the legacy that 5G will leave us with is a mishmash of low-band sub-6G millimeter waves, probably leading to an inconsistent user experience or aspirations. I would hasten to call this an apartheid in a way. There is an apathy to the approach. We are once again creating differences. There are implications which must be considered and addressed. Can I have the next slide, please? So what do we do with the 6G? What bandwidth can we provide? What service are we providing? What user experience we are guaranteeing? Whatever it is, it will be limited by where the weakest link in the chain lies. Serving up gigabit speeds, greater capacity, and ultra-low latency are the needs of today. Operators have densified radio networks with more antennas, so it's easier to get a signal, while cloud technologies and edge computing mean data can be processed closer to latency is much lower. How do you connect to the cloud technologies? How do you take advantage of the edge computing? One needs to know more that just wireless connectivity is not the answer. Perhaps we need more of fiber connectivity as well. Probably this means completely re-architecting the network. We can do it in a cost-effective way. If we don't, what happens to ultra-low latency applications? As an example, is fiber connectivity needed everywhere, regardless of the spectrum used to ensure that user experience is consistent everywhere? We have to identify the weakest link or links. What is it? Fiber or wireless or even real estate? Where, how will you house mobile edge computing sites? Does the current infrastructure support that? Something to think about. Next slide, please. Next slide, please. So we have the previous one, I'm afraid. Balancing act. Yes. So we have to have a balancing act, and this could well be both applications and scalability dependent. But some applications with low latency requirements will need a more ubiquitous network, such as driverless cars, robotics, haptics, or telemedicine, artificial intelligence, etc. The balancing act has to be around speed, connectivity, capacity, the coverage distance, and the latency needs for emerging application. Above all, we might need real-time scalability in future. No one size fits all, but a reasonable fit around parameter is needed. We could do that in generations 2 and 3 because we only had size 0 to cater to, which was voice, but no longer. Do we have a goalpost? Next slide, please. So what are we aiming for? 6G for all or 6G for some? 6G sizing all the way or fixing the first what is and asked why. I have seen what could it be and asked why not. It's fun to get creative and call fancy plays, but at the end of the day, it comes down to executing, delivering on well-defined objectives cost effectively with financial prudence. I stress on financial prudence. I ask myself, what will this G journey be? Will it be a long pass or a short pass to the goalposts, using a football analogy, if I may? The center forward manipulates the goalkeeper. The focus should be on fundamentals. Next slide, please. In conclusion, who will be the center forward in the 6G debate? Will we continue with the cycle of technology, research, followed by a study phase and developing specifications in a neat, iterative manner as we identify flaws and try and reach perfection again at our doors? Is it time to break the cycle, to do it right? And I say this with all due respect to everyone. Let it not just be left to academics, researchers, or industry to be ready to produce whatever comes their way. We need to be mindful of the steps in the journey, user expectations, and financial outlays. Let the telecom industry not take the financial and technological burden to deliver on the promises of the new world needs. Let's do it right. Let's make it a more inclusive process right from the outset. If they don't give you a seat at the table, bring a folding chair. Shirley Chin, first African American woman elected to the Users Congress. Thank you very much.
Thank you very much, Mr. Syngal, for your fascinating presentation. And if you allow me, can I address a question regarding what you presented? You mentioned that we should focus on what are the experiences we're trying to deliver and how do we make sure that they're delivered to everybody, right? In this sense, in particular, you mentioned that the weakest link is fiber connectivity.
So I've lost you there.
Which is true for 4G and 5G and beyond. And in the context of emerging economies, with often challenges with fixed infrastructure, and we see that connectivity solutions are complementary. Policymakers foster the deployment of future-proof technologies, for example, fiber, which are important for all access technologies, including the mobile Gs.
Alexia, I'm sorry. I missed your question because there was a bit of a hiccup.
Sorry. Okay, so you mentioned that we should focus more on what are the experiences that users should have and how to ensure that everybody is connected. And in particular, you mentioned the complementarity of connectivity solutions. And you mentioned that sometimes the weakest link is fiber. And in the context of emerging economies, many times we see that fixed infrastructure is lacking, or we face more challenges. how do you consider that policymakers should foster the deployment of future-proof technologies, for example, fiber, that are important for all last-mile technologies, including all mobile Gs?
You see, first of all, as I mentioned, I think I alluded to in my presentation as well, the G connotes mobility. There was a time when, yes, mobility was the, what I would say, prime facing requirement or element. But today, the fixed mobility, semi-mobility, or all sorts of connectivity, it is completely got blurred, and it is getting, in a way to say, fungible. So it's just not addressing a mobility factor. We need to also look at as to what are the components of the usage or the user expectations and aspirations. What is the mobility requirement? What are the fixed requirements? So let's take an example of robotics. The robotics are in a let's say, shop floor, but they are not all over the place. But yes, driverless cars are a mobility factor. The holographics are there, but yes, they are fixed. The point I'm trying to make is that we shouldn't remain fixated on a mobility factor alone. We should try to now look at various components, various user sectors of industry, humanity, researchers, academics, institutions, hospitals, you name it, in manufacturing industry, and see how bandwidth could be delivered according to their requirements, either by using fixed networks or by using mobile networks as the application requires, in a last mile or in a middle mile or in the first mile itself. We should not just be fixated on the move, is what is that I'm trying to drive at.
I see.
It's no longer just being mobile. It's no longer just being fixed. It's now all sections, and the requirements of connectivity may vary for various sections. So we need to have a holistic approach, holistic view of the requirements in all areas, not just one. The problem with G is it connotes mobility, maybe for historical reasons. I think what we need to say is levels of GBs from MBs, and how do we, in what progression do we achieve those, for which segments, mobile segments, fixed segments, sectorial segments, etc.
Thank you very much for your answer, Mr. Syngal. So from your perspective in the future, will it be a question of coexistence of connectivity solutions? You talked about different connectivity solutions, or rather a question of co-integration of several solutions so that users experience connectivity in a seamless manner?
Again, I think I would say that it has got to be an integration of various types of networks for a good user experience. I didn't mention about fixed wireless access, for example. I mean, we could have fiber connectivity, and then we could have fixed wireless access, or if it is a mobility requirement, you could have mobile connectivity. See, it should be a complete integration of whatever technology can offer to be bespoke with the requirement of a user. We cannot be just wedded to one technology, one approach, and one solution. It's got to be an integrated approach so that we do it right, we do it cost effectively, taking into account practicalities, logistics, and deliver user aspirations.
Thank you very much, Mr. Syngal. Wonderful answer. And thank you very much for your presentation, bringing this perspective, fresh perspective to the table and perspective from India. With this, I would like to now go to our next speaker, and welcome Mr. DongKu Kim, co-chair of the 6G R&D strategy in Korea. Unfortunately, Mr. Kim was unable to attend virtually, and he sent a video to share with us his presentation.
Hello, I'm Professor DongKu Kim at Yonsei University, serving as a 5G Forum Executive Committee Chair. Thank you for inviting me. But I want to begin with an apology that I couldn't join in live session today. Actually, I got to engage in 5G strategy, 5G plus strategy, and 6G R&D strategy in Korea. So in this talk, I want to share some of our lessons from 5G promotion over the last 8 years in Korea and how we can do better in 6G promotion going forward with them in Korea. So I'm going to begin. I want to show you some of the organizations that had their unique missions for the 5G strategy. The first ministry led, of course, strategy and policy. With the 5G strategy committee is still working on and discussing the high-level goals of the 5G diffusion into many verticals. From the leftmost, TTA and RRA, they are responsible for standard. And IITP and Giga Korea foundations, they are responsible for R&D and trials. Especially Giga Korea Foundation has been responsible for 5G R&D and trials over the last 8 years. 5G Forum has been a public-private think tank for the 5G promotion. Finally, NIA, they are the one planning 5G and artificial intelligence business project for the public sector. The key takeaway of the last 8 years is that every mission for the 5G strategy is distributed over different and independent organizations like that. So over the course of a 5G promotion, we found that this kind of a distributed role play is somewhat very inefficient. So we are working on how to make them work together more efficiently in 6G. So 5G Plus is going on until 2025. If the 5G Plus means that 5G diffusion into industry. The ministry announced a serious move to promote 5G promotion. Our ministry, MSIT, announced the 5G Plus Strategy 2019, right after 5G commercialization. They put out the 5 key services, which are the immersiveness, smart factory, auto driving, smart city, and digital healthcare, and also 10 vertical industries to realize these key services. What was challenging in making 5G this plus strategy work? We needed a deeper collaboration in the cross-ministerial level because each key services, they are under different ministerial purview in Korea. So that challenge in 6G is to figure out how to make this system work more efficiently in 6G promotion, because 6G B2B will be more complex and more diverse than 5G. So this is another takeaway, which is we need a deeper and more efficient cross-ministerial level collaboration in 6G. You know what? The last year, the Digital New Deal project started as one of the two key pillars of a Korean New Deal, which provided 2 million jobs by 2025. So Digital New Deal has the following 4 goals that you see in this slide. But basically, there are 2 key ideas, and they are to build a public data dam. Okay, so make a lot of data, state data on public, and adapt 5G and AI to public administration and public infrastructure such as a port, road, railroad, airport, and industrial complex. But thanks to Digital New Deal project, operators and ICT industry got to participate in many 5G projects. So we believe that the ICT industry would have a better chance of developing 5G industry business in private sector in terms of what they learned in this project in public side. But we didn't, I mean, the 5G forum and also the government agency, we didn't get to have enough time to explore and develop public sector use cases prior to these projects, these so big projects. So if we had time, we would have published some white paper of these public use cases. This kind of effort could have made it easier for public ecosystem to better understand 5G prior to the project. And we anticipate that there will be another public promotion in 6G. So we feel like that we should explore not only an industrial business B2B use case in 6G, but also public and societal use cases as we are developing the 6G vision. So now with all those takeaways in the previous slide we saw, I want to share some of recent ministerial efforts for the 6G in Korea. You know, last August, our ministry announced the 6G R&D strategy from 2021 to 2025. It was a meeting chaired by Prime Minister. We shared not just R&D strategy, but also public-private collaboration for the successful 6G era as well. So I'd like to begin with the R&D. Basically, the goal is to secure capabilities of developing core technologies for the first 6G commercialization. It has 3 pillars. The first is to develop 10 core technologies to achieve 6 technical goals. We'll see them in the next page. The second is to lead the 6G international standardization. The third is about to secure capabilities to develop core components of the equipment. You know, in 5G, most of Korean manufacturers, they depended upon global companies for core component development in those equipment. So what they try to do is they try to lead, especially component level, from behind in the early stage of a 6G R&D. And this page addressed the limitation of 5G technologies, which I think you probably have seen many times in other speakers' presentations. And the second column defines the 6 technical goals in 6G. And they are the transmission speed of 50 times faster than 5G, and use of high bandwidth, 1/10 of a 5G latency, and over 10 kilometer range extension, and AI all over the networks, and secure and trustworthy. You can find the 10 core technologies in the rightmost column to make sure there's 6 technical goals. They are terabps wireless communication, and terabps optical communication, and terahertz RF port and propagation, and ultra precision networks, space mobile communication, space satellite communication, and intelligent wireless networks, and intelligent wired networks, and all-time security technologies. So in order to achieve the useful result from these all those projects, the 6G R&D Strategy Committee started off the April. Its main job is to share 6G project results with the experts from industry, academia, and R&D institutes and agencies. Then they are going to propose a kind of a rolling plan for the project each year. You know what? We never had the R&D committee like this in 5G, that all the project leaders are participating. And I think each stakeholders in the committee can have different perspectives for R&D strategy. For example, Korea, the operators experienced in 5G some challenges of a 28 gigahertz infrastructure deployment, right? So that its services are actually lagging behind. So especially some operators, they brought up in the committee a much more cost-effective and much more energy-efficient technology than the current R&D KPIs. So, so it has a R&D promotion TF working on project planning, reviewing, and outcome management. And TF has also 3 small units, right? One is a technology standard, and spectrum, and global cooperation. Then actually, you know what? We have a new minister now, and I think the role of a committee will be expanded beyond R&D. Also, our ministry is now engaging in setting up some of global R&D projects with China and US and the EU with different purposes. Unlike 5G joint research collaboration back in 2013, we now are able to start up a 6G joint research prior to defining 6G vision by ITU, so that we're going to have a better chance of a substantial collaboration for ITU standardization together than when we did in 5G. We are also looking forward to new and continuing collaboration with IMT 2020 and 2030 PG and DARPA and 5G Americas, NSF, Next G Alliance, and 5G IA, University of Oulu, 5GMF, 5G Alliance Taiwan, in the collaboration of technology development, the spectrum, and the policy. So now 5G Forum. So finally, I want to wrap up my talk with some 6G activities of the 5G Forum. We presented the 6G vision from 5G Forum perspectives last November. And we also published the 6G technology report. Our mission is to contribute both vision and technical report to the National Radio Research Agency, which is responsible for the ITUR 6G standardization, so that our contribution will make its way, hopefully, to the national contribution to ITU. You can download them at our 5G Forum homepage. And now 5G Forum focuses more on 6G use cases and public-private ecosystem collaboration. So I want to just share briefly about the 6G scenarios. In 5G forum 6G vision, if you look at them in our the 6G vision file, you can download them. We brought up 4 service scenarios. First is Internet of Experience, the leftmost, right? It'll connect the industry, education, and culture in terms of a new human interface. Augmented intelligence, it'll provide customized information to people according to the situation and needs. Substantial automation, it would complete the digitalization of manufacturing. And embedded AI, it will make a public and social infrastructure digitalized and smarter over 6G. So in the vision, we want to develop not just industrial use cases, but also societal and public use cases as well. Because I told you about it in the beginning slide, we are anticipating another Korean digital New Deal promotion in 6G. So that is why we need to develop not just industrial, but also societal and public use cases as well. You know, over the years, it seems to be, it was very meaningful that operators, for the first time, they got to apply mobile communication networks to connect many verticals. Even though they didn't get to roll out money-making 5G industrial business yet, I think a 5G plus diffusion will go on. So especially in order for 6G strategy in Korea to gain traction in the early stage, I think addressing scenarios and use cases well is more important than it was in 5G. And they should be the ones that all stakeholders agree would be feasible in 2030. So to drive a 6G promotion successful, we need 3 drivers: policy lead, tech push, and need pull from industry and society as well. So 5G Forum is focused more on the need pull from the beginning. So it'll make it easier for 6G ecosystem stakeholders to better understand each other, which we didn't get to start in the early stage of 5G. And we still don't get to well in Korea. So that 5G Forum will work very hard to play a role to build up the industry and societal need pool. Thank you for listening. And if you have any questions, please let me know in my email. Thank you.
So we thank Mr. Kim for his very valuable presentation, insightful presentation. And now we move to our next speaker, Ms. Chang, Chief Architect of 5G Program Office in Taiwan. Please, Ms. Chang, the floor is yours.
Yeah, thanks, Alexia. It's my pleasure and honor to speak in this forum. So today I will focus on the B5G, beyond 5G activity in Taiwan. And plus we have also done a little bit exploratory work in 6G. Next slide. Taiwan has a very strong ICT industry. So disaggregation of 5G infrastructure and the Open RAN open up quite a lot of new business opportunity for many manufacturers in Taiwan. So since 2014, the government sees that the 5G will be a very strategic, important area for Taiwan's ICT industry. Therefore, it started many years program. So the first pre-5G program started 2015 to last 2014 to 2016. The second phase from 2017 to 2020. And now we are in the second phase. The second phase is from 2020 to 2023, and we call it a Beyond 5G program. So in the first phase, we actually have done have some achievements. The government, several agencies have worked together and decided to allocate a dedicated spectrum for vertical enterprise usage. And that spectrum is 4.8 to 4.9 gigahertz. So in the first phase of the R&D program, we also put a lot of effort in developing an end-to-end standalone virtualized infrastructure solution for enterprise network, which include radio access network for sub-6 gigahertz and millimeter wave. And also the virtualized infrastructure solutions. That means the container-based solutions, including 5G-C, 5G core, and mobile edge computing. And as well as several POC trials. The trials including cloud gaming, live 360 video streaming to on-site audience with a first-person views experience. So now we are marching into a second phase of the Beyond 5G program. So next slide, please. So the Beyond 5G program started last year for 4 years. So in this program, we actually put more emphasis on the inclusion of AI and machine learning for network management, application, and distributed edge computing. We have also considered security, 5G securities, and that security program is in parallel of this program. It look into denial of service, detection of denial of service, and the prevention for DDoS attack, as well as RAN security and the open source security, the security from open source, because we have adopted many open source code in our network function virtualizations in our work program here. So the one thing I want to emphasize is in this B5G program, Beyond 5G program, we actually, as I mentioned, put the emphasis on the inclusion of the AI and ML, AI and machine learning for network management, application, and distributed edge computing. So in this phase, OEM operation and the maintenance for both infrastructure and devices are included. We see this is very important for in the future when you deploy a standalone end-to-end system for vertical or enterprise usage. And this will include some of the AI function to detect, to manage the network. For example, the performance management or the fault management there. We also included the Open RAN. We see Open RAN it's kind of path to the futures that it open up quite a lot of opportunity, especially inclusion of AI to enable network management automation or automated deployment. So the radio intelligent controllers, we have put emphasis a task on this particular items. In there, for example, the traffic offloading or the traffic steering or handover that will rely on some of the AI function or machine learning function to enhance the performance in this area. We also have applications, run several applications. Drone racing, smart manufacturing with digital twin, and smart hospital. In smart hospital, we enable location tracking, telemedicine, and AR-assisted medical services. One thing I want to mention is the drone racing here. The drone racing, we envision that drone racing will approach similar popularity as F1 car racing. We will using a digital first-person view, enable digital first-person view in the drone racing application. In here, we plan to build a 5G race field for drone racing with mixed reality. So that will enable audience joining this, viewing this racing activity that can see a first-person view from the drone. The drone will carry a camera, which 5G module built in there. And the drone flying over the field when it's performing a racing, then the whatever drone sees will be transformed back to the audience, and the audience will see a similar view from the drone. We actually put a 5G module into this with camera integrated into the drone, and now it's weighted around 500 gram, and the size is quite small. End of the year, we will be able to do not just an individual drone racing, speed racing, but for competition as well. So this is a particular application I want to mention for drone racing. The next slide, please. In parallel, we also have activity with EU-Taiwan phase 2 target call. We have 2 programs with EU-Taiwan program. One is 5G Dive, the other one is 5G Coming project. And this focus on smart factory. 5G Dive, one is for smart factory using a digital twin, and the other one is drone for disaster recovery. The drone for rescue or first responder case is actually we included AI. It's the same thing. The drone will carry camera and fly over disaster area or emergency, the area that require emergency support. It will detect the person need in help and will dispatch the rescue team to that particular area. That's the application in the 5G Dive. And 5G Coming project will have the data collection and the AI modeling based on the data collected to provide predictive maintenance and remote assistance. Another use case is for connected robot that would be implemented in Bosch factory. So next slide, please. Moving toward 6G. We have organized an expert group to conduct a pre-study on 6G. So it's an exploratory work. Similar to Beyond 5G program, our goal for 6G is to identify technologies that are essential to support 6G services. And then the government decided, funded the advanced R&D works in the identified areas via, and ultimately, we expect that the R&D work done by ITRI or CMAI, which is a 2 research institute in Taiwan, that will perform these advanced research work. As a matter of fact, for the phase 1 and phase 2 work, actually, several Taiwanese manufacturers has licensed the phase 1 result or partner with the 2 institute on the phase 2 work, and expect that result will expand their product roadmap or enhance their solutions for the future 5G, beyond 5G market for the product going to a beyond 5G market. So 6G, for 6G, we have a similar goal ultimately, we would like to see the R&D work can be transferred to Taiwan's manufacturers for production and commercialization. So at this point, we have very small effort in here. The expert group started late last year, and the group is split into 4 specialty areas. Let's move to the next slide. And the 4 please move to the next slide, please. The 4 specialty areas are namely application and communication system, materials, and the semiconductor processing technologies. The group has reviewed the worldwide 60 activities and concluded that 9 anticipated applications, requirements, and technologies to support these applications. So this slide just show the applications area, 9 applications. And these applications also have 3 common features. Either it utilize ultra coverage features of 6G network, or AI-assisted wireless communication network, or interaction between cybersecurity, cyber world and physical world via immersive technologies. So the ultra coverage means like 6G 6G network will not just limited to cellular technology. It will encompass NTN, like a non-terrestrial network, and high altitude platform station. So its coverage will just not limited to cellular coverage. It will cover the land, sea to 10 kilometers above the ground and to remote area. So the first use cases is the unmanned vehicle. Is actually, we envision that this unmanned vehicle will be multi-uses. It can be navigated on sea or on land, and also into sky. And it can be a small to deliver for packet delivery, or medium size for medical emergency vehicle, or even large UAV for tourist purpose. So the smart health and interactive remote robotics. The interactive remote robotics here is, if we see that in the futures, the currently 5G system actually have the remote assistance via AR technologies. The remote system in the remote site, and the expert in the remote area will help the on-site technician to do predict maintenance or to fix some problems in factory production. In 6G, we see that this, instead of personal on-site human beings, it may be replaced by robotics arm or robots to conduct that on-site maintenance issues. Another area is, for example, multi-dimensional massive intelligent IoT devices, that's AIoT devices. In here, we see that every device will have capability to intelligently detect its surrounding environment and automatically decide what it needs to do. Either provide feedbacks to the system, make a suggestion, or perform other action based on its past experience via AI modeling of the user behavior. Ultra positioning in here, we mean that it will have precision location tracking in 1 meter outdoor and 10 centimeter indoor. Also, there's a 3D holographic telepresence applications in there. So this is the applications that or use cases, the expert group actually done some review of the worldwide activities and summarized that these 9 applications may be possible for 6G supported by 6G network. Okay. So next, please go to the next slide. So to support these services, I see I have some limitations here. I'm almost reached my time here. So to support this, these are the 6G attributes. I think I will skip this. You probably see similar requirement or the attributes in many other talks in this workshop. I want to move to the next slide. So what are the opportunities for Taiwan's manufacturers? We see it from beyond 5G to 6Gs, moving from right to left. Core infrastructures there. In software part, we have beyond 5G private network applications there. We may use the intelligent network management and cybersecurity there that to support the future vertical services. In there, and several important things is in the hardware side, switch routers. How do we make a switch routers that have a 5G, some embedded 5G functions there, so that the system can achieve almost close to line rates? The second one is also the in the future, AI is going to be everywhere. So the high performance computing servers will be needed. It will require lots of power consumption and also emit CO2. So how do we make the system to be energy efficiency or to be environmental friendly? There, the emergency cooling system will be play an important role there. Radio access network there, RAN, open RAN, especially with the radio intelligent controllers. In the near real-time radio intelligent controller or the non-real-time radio intelligent controllers. Those functions will help the system to improve the performance of the system during the handover. For example, the drone, when you are flying in quite fast, you hand over from one to another station or one to another cell. You definitely will need some of the AI to assist you to do a prediction of which cell you're gonna hand it over, rather than relying on the ordinary approach for handover, the basic approach, a cellular approach for handover. The end devices, the modules, smart modules, smartphones, and the AR, VR goggles that will need the 5G devices included in there, and with lightweight, low power consumptions. And last but not the least is the low power consumption, high capacity component and chip technology. We see that this we will require a new material and new processing node in semiconductor processing node in order to make a high efficiency PA as well as a low noise LNA. So these are the potential areas for the component and RF component modules. Next slide. In the end, I want to summarize. 6G may be best for applications associated with immersive technologies. But how do we make it to be environmental friendly and sustainable? Not mentioning 6G, beyond 5Gs. We know 5G actually consume quite a lot of power in the current deployment. How do we make our system to be more, less power consumption and to be more efficient? So these are the questions that our challenges, we all need to face it and we need to address it before we move into 6G era. Thanks to your attention. Thanks for your attention.
Thank you very much, Ms. Chang.
Thank you.
So we're running a little bit behind schedule. I did have a question for you, but I think you answered it in one of your slides, which is what were the elements of the ecosystem that can be strengthened for the next generation of wireless connectivity? So I will take it like you, in one of your slides, you went into depth into that. So if you don't mind, I will now go to the next speaker. We're running behind.
I'm sorry for running over times here.
No, it's fine. We have the honor today to have Mr. Zhisheng, professor at the Department of Electronic Engineering at Tsinghua University of China. Mr. Niu, please, the floor is yours.
Hi, ladies and gentlemen, good morning or good afternoon. My name is Zhisheng from Tsinghua University, Beijing, China, currently serving as the liaison person for international collaboration in National 6G Promotion and Expert Group of China. Next, please. Okay, so here by 6G, I simply means the mobile communication and the networking around the year 2030, without any specific definition on any particular technologies. And so if we have to say something about that, I think it could be called mobile things or machine-centric mobile communications embedded with more intelligence together with 5G. In comparison, the first and second generation are dedicated to the mobile phone, and the third and the fourth generation was dedicated to the mobile internet. And the next, please. Okay, the next, please. Okay, so to better understand what 6G should be, we need to first to understand what 5G is or will be. As one of the leading markets in the world, Chinese operators have started to build their 5G trial networks since December 2018. On June 6, 2019, Chinese government released commercial 5G network licenses to four operators by allocating the low and the middle band spectrum as shown here. It is worth to note that except the existing three major operators in China, so-called China Mobile, China Telecom, and China Unicom, a new operator called China Broadcast also got a commercial license for 5G. This is indeed a big change in Chinese mobile market. It does not only mean just another competitor, but also mean more broadcasting type applications or contents like video streaming, live broadcasting, etc. will be integrated into communication networks. For example, China Broadcast have announced a close collaboration with China State Grid to empower a nationwide smart grid in China using 5G technologies. Another point you may have noticed is that high band spectrum, that is a millimeter wave spectrum, has not yet been allocated at this moment in China. Next, please. To be more specific, the three major operators in China have announced their 5G service packages as well as their commercialization plan. Totally in year 2020, China have invested 260 billion RMB in 5G networks by building 718,000 5G base stations, which is about a 70% share of the global 5G networks. With this infrastructure, Chinese operators have successfully contracted more than 200 million 5G users in year 2020. And this number is expected to reach 822 million by year 2025. Among all the newly sold handsets, more than 90% of them are with 5G functionalities. Another interesting thing is that China Telecom and China Unicom have decided to jointly build 5G networks in order to compete with China Mobile. This is not only because the very initial the very high initial investment cost, but also because the very limited resource to find a location for the ultra-dense 5G networks. The next, please. For the killer applications, a survey by Chinese Academy of Telecom Research have shown that 4K, 8K high-definition video, AR/VR, UAV surveillance, remote control of mobile robots, and industrial internet are the most promising applications of 5G, which take a share of totally 50%. Of course, mobile pays are also very popular in China. For example, more than 80% of payments are paid by mobile in China in year 2018, compared with 25% in Japan and 12% in France. Next, please. So clearly, 5G is not perfect at all. It probably have to be focused on EMBB and MMTC, but leave most of the part of URLLC to 6G. This is because as mobile things or industrial internet grows, one needs to remotely control different type of machines, such as vehicles and robots, through sensing, learning, and actuating. Therefore, ultra high reliable and low latency guarantee of the sensed information, as well as the action decision, is crucial. The next. This is why we need to extend the URL communication to include URL computing for timely and adaptive mission control. The next. In addition, 6G needs to add another 3 keywords on top of 5G, which are autonomous, the next piece, and green, the next, and also the trust. So next slide, please. So, so here by autonomous, I mean on-demand and autonomous service provisioning. That is to say, by sensing the traffic and the network context information, network itself can self-learn, self-organize, self-optimize, and self-evolving by using the big data and the machine learning technologies. Based on that, the network controllers will adjust the network slicing and the end-to-end KPI management. For this purpose, we need to study multi-dimensional and multi-scale sensing and timely status updating, and edge learning and AI-based decision-making technologies. The next slide, please. So by green, I mean not only energy efficiency, but also the energy sustainability. As we have known, the energy consumption of the typical 5G base station is 3 or 4 times of that of a 4G base station. And in order to provide a similar coverage, it may need 3 or 4 times of the 5G base station compared with 4G base stations. As a result, the energy consumption as well as the total cost of 5G network would be much higher than 4G networks. One of the potential solutions is to more aggressively turn off the underutilized base station as well as edge servers. Another potential solution is to incorporate more renewable energy by energy harvesting technologies. Therefore, the hypercellular network architecture, which can adapt to the traffic variation by controlling the base station or edge server sleeping, need to be implemented. The next slide, please. Last but not the least, by trust, I mean not only the trustworthy computing, communication, and control, but also ubiquitous and unlimited connectivity, which is extremely important for 6G. For this purpose, to only list up a few, for example, the infrastructure-assisted authentication and the blockchain technology, as well as the space, air, ground integrated network would be the keys. The next slide, please. So based on the above mentioned understandings, China have started the pre-researches on 6G while supporting the commercialization of 5G networks. On January 2018, the Ministry of Science and Technology of China, so-called MOST, have started to incubate the beyond 5G and 6G researches on these 4 topics through the funding framework of National Key R&D Project, which is a 5-year research funding program in China. Only 2 months later, the MOST set up a new research category called Mobile Information Networks under the framework of National Major Science and Technology Project, which is a 15-year research funding program through which a new concept called full coverage, full spectrum, and a full application has been proposed. Then on May 2019, the Ministry of Industry and Information Technology, so-called MII, kicked off a 6G technical working group within IMT 2020 organization. Most recently, on November 2019, the MOST kicked off an even bigger national 6G expert group, consists of 37 experts from government, academia, and the industry. On 2020 December, MOST granted 15 research projects on 6G under the framework of national key R&D projects. So this is the current status of Chinese R&D research in China on 6G. So meanwhile, the next slide, please. So meanwhile, to better promote the international collaboration, we have organized the first global 6G conferences in September 2020 in Beijing by collaborating with a 6G summit in Finland. It has attracted more than 80 speakers from all over the world and more than 300 on-site participants from local China. So the next slide, please. The next global 6G conferences will be held on November 10 to 12, 2021, this year, probably in Nanjing, China. All of you are warmly welcome. Thank you very much for the kind attention. So that's the end of my, I stop here. Thank you very much for your kind attention.
Thank you very much, Mr. Niu. This was a fascinating presentation. And you do mention the importance of having more base stations giving the data transmission requirements, but at the same time, you mentioned green GE as being part of the vision. In your perspective, what are the most promising technological aspects that may influence sustainability of networks going forward?
Oh yeah, so as shown in my presentation that yes, green aspect is the most important aspect for 6G, I believe, because the spectrum, we need to higher and higher spectrum. So for that purpose, in fact, we have to, on one hand, to save energy. So that means by turning off or making the base station go to sleep. It's not only for base station, but also for the computing server, because in the 6G, we will have more and more edge servers. So, on one hand, we need a power saving technology for this base station and edge server, but also on the other hand, we need to consider the renewable energy. Renewable, how can we better utilize the renewable energy for our future communication and computing? That is very, very important.
Thank you very much, Mr. Niu. And this, please let us give all our speakers a big round of virtual applause. It has been a very informative and insightful session. And I thank you very much, all of you, for your interventions. And it was a pleasure moderating this session. Thank you.